Hello and welcome to this segment of Introduction to Autonomous Systems. In the last session, we started tracing the early evolution of the artificial intelligence discipline, and we had reached a point where, while many things had happened, there was also certain difficulties or roadblocks that were encountered. Now, in order to address those issues, the next significant contribution to AI came in the form of the next level of developments that we will look at in this session. So, let us begin today's session. In this particular phase, there was a recognition of the fact that we now needed to reduce the combinatorial explosion because of the scalability requirements, and essentially it meant that we needed to narrow down our search space for the solution, so that we could manage the whole process of search within the available resources. And this also led to developments where the main idea was to not use very complex search strategies that would take a lot of time, but to use simple search strategies which did not take too much of time, resources and effort, but club them with the disciplinary knowledge so that they had to look for solution in a limited search space. Now, this was an important change in the way people were looking at artificial intelligence discipline, that now we needed to have the disciplinary knowledge to be able to create an effective system. And this philosophy of bringing in the disciplinary knowledge also led to the development of domain specific AI tools and systems. If you recall, initially the whole discipline of AI and the computers for AI application were looked upon as general problem solvers. But now there was a shift in the focus and perspective that we needed tools which are domain specific. So, one of the very early development in this regard can be thought to be Dendrel. It was the first such AI system, came around 1969. It was also the first knowledge based AI system, and it was primarily used for identifying unknown molecules in organic chemistry. So, this was the first effort in trying to bring the disciplinary knowledge from organic chemistry to set up an artificial intelligence system for identification of unknown molecules, and also started looking at AI systems where not only the knowledge came from a discipline, but knowledge came from experts, the human experts. And these systems were called expert systems. In order to differentiate it from other systems where not only the disciplinary knowledge, but the opinion of an expert also was taken into account in setting up an AI system. One of the notable among these was the MySyn, a medical diagnosis tool that was based on the experience of doctors, medical uncertainty, as well as the knowledge from the medical or the medicine discipline. In fact, while these were happening, people also realized that AI system would need processing of natural languages, particularly if they had to come down to the level of human like intelligence. And the first initial attempts were configured with limited scope of syntactic translations, which means using the syntax of the language, you would use that syntax to translate a particular statement or a phrase into what could be processed by the computers. Of course, this had a limited success, and the researchers realized quickly that more robust language understanding would need general knowledge about the world as well as a generic strategy for using that knowledge. It essentially reflected the whole idea that language is lot more than its syntax. It works in a context, it works in a scenario, in a geographical domain, and all those things which are happening in those areas ultimately have an impact on the way the language is spoken, interpreted and understood. In fact, this is where one of the basic premise of there is no syntax started, and people started now looking at ways to incorporate language understanding and represent and reasoning with knowledge, bringing in the stereotypical situation of a particular context. So, all these which we as humans do it intuitively or even without realizing subconsciously had to be brought in the whole domain of natural language processing. With all these developments taking place in the mid to late 70s, in 1982, DEC, that is Digital Electronic Corporation, employed an AI expert system, and from that point onwards, over the next 5 years, AI as an industry grew exponentially. So much so that by 1988, it had become a $1 billion empire. Of course, the growth of AI as expert systems also led to hundreds of companies building expert systems in various areas of robotics, vision systems, software, hardware components for these applications, many engineering applications such as structural analysis of complex objects. They all ultimately were served by different kinds of expert systems. But again, very soon most of the research in the domain of expert system was also shelved due to failures to deliver on promises made as part of that what that expert system could do, because they all had limited success. And again, there was a temporary break in AI related activities. The whole thing had a kind of a rejuvenation when an important development in the domain of algorithm, which was primarily used by control engineers, called the back propagation algorithm, and was used in the field of neural network, that the AI related research again got revived. Because with that, there was an important element which got added to the AI research, that it brought in the idea of corrective feedback, which means that if there was an error in the prediction or a solution or a result, there was a mechanism to go back and do the correction. And with this, there were many problems of learning in computer science to which this was considered to be an important contribution, the backpropagation algorithm. And of course, this also brought into focus the connectionist model of any intelligent system that appeared to compete with the existing symbolic model of Newell and Simon. Initially, all the models of the neural network were symbolic models, but with this, people also realized that a network based interpretation of a neural network was also applicable. And in fact, the current thinking is that both symbolic and connectionist models are not contradictory or competitors, but are actually complementary to each other, and they together only are able to explain with reasonable confidence the human cognitive behavior. Thus, the neural network research now has split into two parts. One, creating network architectures and algorithms, while the other modeling the empirical properties of actual neurons and their ensemble in terms of what kind of, whether it is a two position on off model or whether there are intermediate positions of neurons where one can create a more, instead of discrete, a continuous model. All these ideas are now being explored together. In fact, there was another thought process when the AI discipline started, that the field would be free from classical theories, that it would be based on intuitions, symbolic computations, and probably would not have rigorous analysis and experiments, which were considered to be the main hallmark of the classical theories. The whole idea was to get away from mathematics, operations research, cybernetics, which were essentially based on rigorous analysis, experimentation, and related activities. In fact, in the present, this also has undergone a change with the greater realization that instead of proposing newer theories, it is better to use existing ones and show relevance to the real world applications. It is now seen that machine learning needs information theory, uncertain reasoning and stochastic modeling for better results from search algorithms through optimization and control. So, people have realized that stochastic modeling, information theory, optimization and control are all necessary to create good search algorithms. In fact, AI has now, to do all this, embraced many scientific approaches which are lot more rigorous in terms of mathematics, such as hidden Markov models, statistics, pattern recognition, data mining, Bayesian networks, and many more similar tools which are already available in the many rigorous theories that are being also considered as possible candidates for application to artificial intelligence. In fact, earlier disciplines like robotics and vision were considered very specialized disciplines, and they were removed from AI and were progressed separately. Now, AI is bringing all of them back together with overall benefit for both through mathematics and machine learning, which means AI learns from these disciplines the mathematical aspects, while these mathematical aspects learn from AI the idea of machine learning and trying to improve and self correct and probably come closer to what a human would think and what action a human would take. So, at this point, what AI is propagating is the concept of an intelligent agent we will be discussing in subsequent sessions. And by bringing in this idea, AI essentially is bringing itself closer to control theory and economics. Those are the disciplines which are now being considered as an important element of any AI system development. Of course, there are always counterpoints where people feel that this perhaps is not a good thing for AI as a research discipline, and there are suggestions that AI should instead create improved versions of specific application to some extent, but then should go back to its original goal of designing machines that can think, learn and create. So, go back to the solving of open ended problem, that is create general problem solvers. And first level of efforts on this count are on to create what we call a human level artificial intelligence called general intelligence or artificial general intelligence AGI, that is essentially a universal algorithm for learning and acting in any environment. In this regard, I think we should take a note of this fact that we are also now in the age of very large data from countless sources. If you look at our social media, the information explosion is unbelievable. While quite a lot of it might not necessarily be useful, but also there are a lot of content which are quite useful, and it is important for us to take cognition of that fact, that how can we benefit or how can the AI benefit from availability of such very large data. So, the research is now debating whether algorithms, which have always been a strong point of computer science, are really that important, or that we should be more concerned about the suitability of the data itself, because there is so much of data available. The data fidelity, its sanity has now become an important aspect that needs to be checked at every stage. And as time progresses, we will find that these will become the real driver for any AI system. In fact, there are studies that have established that using a very large data set and a very simple search algorithm works much better and faster than any complex algorithm with limited data. The reason for this is that when you have a limited data, unless the data is of a very high quality, no matter how good an algorithm is, it is not going to give you very good results. On the other hand, if you have a very good or a very rich data, then an algorithm which is not really very complex would still be capable of finding good solutions, because the data itself is fairly good and reliable. So, if we were to now come to a point of looking at where the AI is now heading and what are all the dimensions of its reach, we realize that it has invaded almost all the aspects of our lives and will continue to do so as we progress further with AI tools. And the case in points we already have with us generative AI tools such as ChatGPT, Gemini, Copilot and many more are in the works. In fact, an incomplete list of the reach of AI would include robotic vehicles, speech recognition, autonomous planning, scheduling, gaming, spam filters, logistic planning, machine translation and the whole lot of activities that as humans all of us keep doing all the time, and we are hoping that at some point there would be machines also who would be doing the same thing. So, if we were to conclude this part, we would say that artificial intelligence in recent times has significantly expanded its reach with both generative AI as well as the agentic AI solutions. And there is also a realization that availability of large data set in almost all domains has the potential to simplify the search algorithms and simultaneously optimize the processing timelines. So, with that we close this particular segment, and in the next segment we will progress this particular topic further. So, it is bye for now. Thank you and see you in the next segment.